Hello guys, my name is Desmond and I welcome you to my lesson for today where I'll be looking at mathematics paper 2. Let me just open the question paper there. So you guys did confirm to say everything is clear, isn't it? For the last time, LB, can you just confirm for me if all is in order on your side?
Yes, sir. I can see everything.
Okay, 100%. So, ladies and gentlemen, please do allow me to say it's very much important that I say it's very, very much important, ladies and gentlemen, because what I'm about to say it's massively, 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 massively. Hey, massively important that I say a day without learning something new, it's a day wasted. By so saying, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Okay, so obviously I've indicated that we'll be looking at your mathematics paper 2. So this is DBE 2021. So ladies and gentlemen, I suppose in this lesson, it's either you're doing grade 10, 11 or 12. It doesn't really matter that much. You know that I do master lessons where I accommodate all the grade 10s, 11 and 12. So ladies and gentlemen, let's have a look at question number 3. So what I'm actually going to be doing is to read through. No, that's not what I want. I want a pen. So what I'm actually going to do is to read through the given statement, do an interpretation of what we're given over there, and most importantly, ladies and gentlemen, go through those questions over there and try to explain in terms of what type of questions you might be facing and how to approach them, and most importantly, we should be answering all of those questions. Okay, I suppose everyone is ready to start with me as I tackle this question paper. Okay, so let's see. What I'm going to do quickly is just to read through the given statement. So in the diagram, S, remember, I've always been saying that S, it represents a point. And then these okay, guys, so I'm back again. I noticed the screen went away. Let me try to share again and see what happens. I'll just need someone to confirm. Let me see who's on the line. Kogetsu is there. Can someone just confirm for me if the screen is now sharing?
You can see it.
Okay, 100%. So let's continue. So I was busy saying we've got point S with the coordinates where x is 0, y is negative 16, and then L and Q. So these are the vertices of triangle SLQ, having LQ perpendicular to SQ. So ladies and gentlemen, it is very much important that for every sentence that you are given, you must be able to interpret it. So obviously, they're talking about a diagram with these coordinates or point S, L, Q. They say these are the vertices of that triangle, having LQ being perpendicular to SQ. So let's try to check where are those. So where's point S? Okay, there's point S. And then where is L? Can you see there is L? It doesn't have the coordinates. That's why there they just indicated to say L. And again Q. So Q, it has the coordinates. Where's Q on the diagram? There is Q, ladies and gentlemen. So they say these are the vertices of triangle SL and Q. So it's very, very much important that you are able to interpret this type of things. This is a triangle. A triangle of what? Of point S, point L, and point Q. So the sentence continues to say having let me just remove that and see what's going on. Okay, so they're saying triangle SLQ having LQ. Where is LQ? Let me check LQ again. There is L and then there is Q. Okay, so remember, I've always been saying when the given information is written in capital letters, it means they're talking about the distance from L to Q. So that means they're talking about that straight line, ladies and gentlemen. So they're saying that line is perpendicular to S, what is it? LQ, perpendicular to LQ. Let me just check if I'm not missing something there, ladies and gentlemen. Okay, no, I'm not missing anything. So we are talking about two lines there, being LQ and again SQ. So they're saying these two lines are perpendicular to each other. So if you've been attending my previous lessons, you will remember that when you have in perpendicular lines, when you multiply the gradient of one line and you multiply it with the gradient of another line being perpendicular to that line, you are having a, what is it, -1 when you multiply the gradients of those two. So I've got an idea, guys, especially for those of you who discovered my channel at a later stage. What I'm going to do is to prepare a complete lesson where I teach everything. By everything, I mean I bring my old notes that I was using to study, and then I just compile everything and do a very powerful lesson whereby every time when we have to do, let's say, for example, this chapter of analytical geometry, I don't have to present that intro again, because if I do it, I might forget some of the information. So it's better if I have a recorded lesson of which I'm going to play to everyone. Also for one-on-one lessons, I'll play it. Then we'll be doing live lessons only when we're solving or treating a question paper. In that way, I know that in that prepared lesson, I'm going to cover everything. I won't miss everything. So even when you're going to practice, you'll just watch that lesson and forget about having to study or maybe go through your notes and whatever. It might take some time. So you just know that I've prepared maybe a 30 minutes lesson which covers everything. So in 30 minutes, you have done a summary of all that you need to know. I hope you guys might appreciate something similar to that. But anyway, let's continue, ladies and gentlemen. So remember, guys, everything that I'm doing now is just to get you ready so that when we go to fight those questions, you'll have a bit of a background of how to interpret the given statement and the given diagram. So don't do what I'm doing in exam. Just straight away read the statement and then have a look at the given diagram if it's there. From there, tackle the questions. So let's continue, guys. Where are we? Okay, so I think we are now heading to the next or the second sentence over there. Okay, so let's see. They're saying SL and SQ are produced 2 points R and M respectively, such that RM is parallel to LQ. You remember, guys, we did talk about the word produced. The word produced. So, in other words, that word being produced you can actually regard this word as a line being extended. So it's more like you are having, for example, let's say a line up to that point there, that point being D, for example. So when we say we produce MD, or we produce line MD, we are simply saying in the same direction at the same slope, we just produce it to pass or cross or intercept either the X or the Y axis. So don't be confused, ladies and gentlemen, over there and say, hey, that's a big word produced. Or otherwise, for some of you guys who wants to be DJs in this group, don't think about a producer there or whatever. Just know that mathematically, when we talk about produce, we are simply talking about a line being extended to cross, touch, or intercept either the X or the Y axis. Very, very much important, ladies and gentlemen, that at all times you pay attention to every detail. So let's see. Where are we? Okay, so I was explaining that word produced, but I think I've explained enough there. So they are saying it's S, L, and SQ. Let's see where those ways is. There's S and then L. Okay, and again S and what else? And Q. There's Q. What about those? Those are produced to points R and M. Where is R? There is a R. Where is M? Let me see. Oh, there is M, respectively, such that RM is parallel to LQ. Okay, where is RM? Let's see, where is R? Oh, there is R. M, where is M? There is M. They are saying it's parallel to LQ. Where is L? Okay, there is L. Where is Q? There is Q. Oh, now it makes sense. So in short, they are simply saying that line is actually parallel to that line. So I hope that make perfect sense. So I think we can now try to move to the second sentence. So ladies and gentlemen, I'm just trying to explain to you how you interpret the given statement going sentence by sentence. Are we still together there before I go far? Are we still together, guys?
Yes, sir.
Shreyas,
Yes, sir.
LB confirmed. Last one to confirm, Ndlov, are you there? I'm not sure what's going
Yes, sir.
on, LB. Let me now check what's going on there. Okay, Elton is there. He confirmed. Okay, it's fine. Let me now proceed. I suppose we are all on the same page. So, let's see, 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 let's see. Okay, so this is now where I am. I think I'm just going to remove all of that because I think I've explained all that you needed to know regarding that. So, remember, guys, this lesson is being recorded just in case if you feel like it was useful and might need I think I can only say to you via inbox. One thing for sure, if I have posted, I'll only manage to post it. But I'll try if I can upload it over the weekend. So let's you guys. I think this is where we are now. Yes. So the moment you mention the letter, the moment you mention the letters, or exit is that letter. Sm produced past the axis n. Oh no, this is Sm produced the x-axis point n with coordinates 8 and 0.
Sir,
M. So this is S A with there are things being produced to cut the x-axis at n. There is n.
sir, there's something wrong with your network if you can hear me.
Those coordinates. Okay, now it makes sense. So I think all of you guys, we now understand what the word produced means. Don't you, Yibu? You want to say something? I noticed load sheet might things like will be not not sure if hear me. Shreyas, quick, Shri, who Elton? Elton, can you hear me there?
No, sir.
No, sir.
It's in. Let's see. Tando,
Yes, sir, we can hear you, but the screen is not visible.
It's visible now.
Shreyas is saying no.
The screen is fine. It's just that the messages are getting
Can I
delivered
have
late.
someone to confirm, guys, in case if
Sir, you're breaking up.
someone else to confirm the screen is still not visible.
Sir, the screen
Is it
is
okay?
fine.
Let me try to go to the or delay into the mistake. So
Yes, sir.
let me try to continue just in case if you notice still breaking. Okay, let me try check something. But sure, the screen is.
Sir.
Okay, guys, I'm back again. I noticed the network was bad on my side because of load shedding. So let me just try to share my screen. Someone will just need to confirm for me if the screen is now better. And again, if you can clearly hear me. Can someone confirm for me? LB, is it fine now in terms of the voice and again the screen?
Yes, sir.
So, is it fine for everyone? Can someone, the last one, to confirm? Elton, is it better there? Is my English coming out of my nose?
Yes, sir.
Okay. If that is the case, okay, I'm back again. So I'm expecting this to happen multiple times because of that disconnection with my Wi-Fi. So now I've actually hotspotted myself. So this might be happening for some time. So because I'll be looking at my question paper, I will need someone to serve as let's say a class rep for today's class. Sure, yes, but I think LB's network is proper. LB, can you hear me properly?
Yes, sir.
Okay, so every time when I say attention, you'll be saying yes, sir. And the reason for that is for me to know if all is in order. If you don't respond, then I'm going to try check what could be the problem. Let's try it. Mic check, 1 2 1 2. Attention.
Yes, sir.
Yes,
Hey,
sir.
yes,
Yes,
sir.
sir.
Hey, it's nice to be said. Let me see
Yes, sir.
who's new. Mukele Machaya. I think you're attending my lesson for the first time. But listen to this, Mukele. Attention.
Yes, sir.
Okay, so where are we? Okay, we are done with that first sentence over there. So now this is where we are. QM is equals to MN. There's a full stop there. So that means what I'm doing, ladies and gentlemen, I'm interpreting each and every sentence given. How do you notice a sentence? That's when you have whatever letter starting after a full stop. Then after every full stop, I need to interpret. Let's say, where is Q? You need to be aware of exactly where is Q. Let's see. Okay, there is Q. Where is M? There it's M. And then again, they are saying this is equals to M. And where is M? Again, that same point. Where is N? Oh, that N is that one which is produced. Okay, so you can even see, ladies and gentlemen, we are having this thing to show that these two lines are actually equal. Okay, so now let's proceed. T and P are the y-intercepts of RM and LQ respect. Remember, ladies and gentlemen, remember, when you are given just one letter, this means it's a point. When you are given two letters, and remember, I'm talking about capital letters. When you are given a capital letter, which is just one letter, it means it's a point. So T there, it's a point. P there, it's a point. But when it's given like this, as two letters, we are talking about a line. So which line are we talking about? The line of RM. So let's see, where is that line? Where is R? There is R up there, M is there. Okay, so this line, and again LQ. Where's LQ? Okay, there is LQ. So those two lines, they are saying T and P are the y-intercept. Where is T? Okay, we now need to look at T. T is there. Okay, there is T. Where is P? There is P. Are they y-intercepts? Yes, they are y-intercept. Where is the y-axis? There is the y-axis. Okay, now it makes sense. But remember, guys, most importantly, when we talk about point T, we are talking about that point there. That point there. So P, it could have been written somewhere there, but we know very well that this is the point that we're talking about, which is the y-intercept. And most importantly, we know that at point P, something we already know. We know that y is equals to unknown and then x is 0. And again for T, same thing. X is 0, the y value is unknown. So I think I've actually explained all that I needed to explain with regards to the given statement. So now what I want to quickly do is to go through the given diagram. From there, we are going to be fighting those questions. But guys, attention.
Yes,
Yes.
sir.
Yes, sir.
Okay, that means
Yes.
we are still on. Let's see. So, ladies and gentlemen, always, when you are given a diagram, the diagram is drawn on a Cartesian plane. What is a Cartesian plane? A Cartesian plane is two lines. What are those lines? The first one is this one that we call the x-axis. The second one is this one that we call the y-axis. This is what we call a Cartesian plane, ladies and gentlemen. And it only becomes a Cartesian plane if you label to say this is y, and then you label to say this is x. And most importantly, a Cartesian plane has got the origin. So everything is drawn on a Cartesian plane. So what did they draw on that Cartesian plane? You can simply see that they actually drew that line and again that line. And on top of that, they also drew this line and again that line. And what they said is that this line of L and Q, it's actually perpendicular to that line over there. Because you attend Mr. Sibanda's lesson, he tells you that if you have parallel lines, they've got the same gradient. So for the fact that this line forms a 90-degree angle there, and again this line and that line, they are parallel to each other, that means also there we are having a 90-degree angle, which is something that examiner doesn't tell you, but they expect you to know. How will you know, ladies and gentlemen? You don't have to pray and fast and what else? You don't have to be a nice person to know these things, lady. You just need to attend our lessons. It's as easy as that. LB, complete the missing word. I know you will get it right. If you don't get it right, I'm going to mute you. This is what you need to complete. You get it. If you don't get it,
Forget about it.
that means we are still on. So, ladies and gentlemen, let's now try to proceed to the next part of our question paper. So I think I've covered almost everything that I wanted to cover. Let's see. Okay, so the last thing that I can say, ladies and gentlemen, before we start with our questions is that from this point in that direction, you've got positive x values. From that same point in that direction, you have negative values. And then again, I would say from that same point, it's positive y values. From there down, it's negative y values. Why am I saying this, ladies and gentlemen? It's because every time when you calculate, for example, if you have to calculate the coordinates of P, expect a negative y value. Also there, expect a negative y value. Just like there, you've got a negative y value. So because these points are along the y-axis, that means we already know that x is 0, that is unknown. X is 0, that is unknown. So if you had to calculate the coordinates of L, just know that you're expecting negative x value and a negative y value. For R, negative x value and then a positive y value. I'm not sure, ladies and gentlemen, before I start with 3.1, if there's someone who's got a question, or otherwise, did that make sense to everyone?
It makes sense, sir.
But does it make sense to everyone before I make a conclusion that we are all on the same page?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
100%. So now, let me try to do this as we try to answer upcoming questions. Okay, so let's see. the first question being 3.1, it says, calculate the coordinates of M. So remember, guys, I've always been emphasizing throughout the year that we've got what we call the cream of the question. What is the cream of the question? So the cream of the question is that weight or those weights when removed from the sentence or a question, the whole of that sentence or question will remain senseless, or it won't make any sense. You must apply this when you're dealing with your mathematics, physical sciences, life sciences. It could be geography, accounting, economics, or whatever, and that includes history and agricultural sciences. So just make sure that you apply that. I think I'm in a better position to try and explain to you guys exactly what I mean by that. So let me just try to do this thing, guys, and see if it's going to work. Let me see. No, that won't work, but it's fine. I'll just, okay. Let me do this. Okay, this is exactly what I want to do, ladies and gentlemen. So let's see. You are given a question which says calculate the coordinates of M. So now, how do you identify the cream of a question? I know it's easy, but I just want you to have an idea of what I'm talking about. So that means on the upcoming questions, I won't really have to go word to word to explain what is the cream of the question. So I will just use this first question. 3.1 says calculate the coordinates of M. So is this word calculate the cream of the question? How do you know? Just try to imagine that word not being there. What's remaining? You remain with the coordinates of M. So can you see? You can still answer the question even though you don't have that word calculate. So let's try the second word being there. So you have calculate coordinates of M. You can still provide an answer or respond that question. Let's check the next word. So can you see? Calculate the of M. So you are not sure whether they want you to calculate the distance, the gradient, the midpoint, the whatever of M. So that means, ladies and gentlemen, what I've hidden there, it's actually the cream of the question. So let's now see. So if the coordinates is the cream of the question, if the coordinates is the cream of the question, ask yourself this question: how do we represent the coordinates? So that means your final answer must be something in this format, because this is how we represent the coordinates. Anything else, it's not the coordinates. So if your final answer, ladies and gentlemen, it's a signature, I'm going to give you a very big 0. Why am I going to give you a very big 0? It's because a signature is not the coordinates, ladies and gentlemen. If you say 2 and 4, ladies and gentlemen, these are not the coordinates because I'm not really sure if you are trying to give us a pattern and you forgot to just continue there and say 6 and whatever. It only becomes the coordinates, ladies and gentlemen, if you do this. Then we know you've given the coordinate. But now, the coordinates of what? Is it the coordinates of R? Is it the coordinates of L, T, P, whatever? So, the coordinates of M, then we know we are talking about that point being M. So it must be M as a point with these coordinates. So I'm just trying to explain to you guys to say, every time when you know what is the cream of the question, you put yourself in a better position to answer the question correctly. So remember, guys, you might be in grade 10, 11, or 12, or you might be a tutor, or you might be a teacher attending my lesson. The aim is not really to just show how smart we are. The aim is not really to rush to answering the question. But I've noticed that the more I talk, the more you guys are able to learn Hey, guys, before I forget, I might have said this, but I like saying this because, you make sure to have the aim when attending my lessons. Ladies and gentlemen, a day without learning something new, it's a day wasted. So just make sure that if since morning you haven't learned something new, just make sure that out of this lesson you learn something new. So for each and every question that I interpret, there must be something new that you can learn. So that is why some of you guys who are that much intelligent, you might need to be patient with us as I go through the questions step by step. I'm not sure if there's someone who wants to try how to tackle this question, but remember, guys, in my lessons, just make sure that if you want to give it a try, mention your name, then I'm going to recognize you. And the reason for that is because some of you guys have got a stronger connection. So this question that I'm asking, immediately you can get it instantly. But for someone who's in, let's say in Mpumalanga, that might take some seconds for this question to deliver. So you might find that they want to participate, but because the connection is a bit slow, they are not able to. So that is why I want you guys to just mention name and I'll recognize you. So there you go. Guys, anyone who wants to try the first question, just mention your name.
Mokhele, sir.
Who's that? It's a new name. Mukhele. Did you say Mukhele?
Yes, sir.
Mukhele, can you go for it? You are recognized, honorable member.
So, sir, we are going to apply the formula of midpoint. So we are going to use the coordinates of Q and N, since they've told us QM is equal to MN. So we are going to say for Q we are going to say X1 and Y1, and for coordinate of N we are going to say X2 and Y2. So when we substitute from the formula of a midpoint, we are going to say
Okay.
X1.
Okay. You can cut it there, Mr. Mukele. I think you are on the right track, just so that we don't lose each other. Let me continue with exactly what you're saying, but writing it down somewhere. So I think I might as well just write it there. So, ladies and gentlemen, on behalf of Mr. Mukele, in which province are you? I'm guessing you must be in eThekwini.
No, sir, I'm from Free State.
Oh, Free State. Disipela yuanga mo Free State ntate.
Se dikela sharp.
Disipela sentle. Renale someone ojo Free State ba re ke Ferdinand. Ferdinand, are you there? How's the lesson? If he's there, he's going to answer. I know. You will hear what he's going to say. Ferdinand. Seems like Ferdinand, he is not there. Okay, so ladies and gentlemen, what a gentleman has said over there, he's saying this is the formula that we are going to be using to calculate the midpoint of point M. So what is the midpoint, ladies and gentlemen? The midpoint, it means you must be having one point and another point somewhere. Then if you join these two lines, for example, A and B, the midpoint is a point which is actually in between or in the middle, just like the word says, the midpoint. So in short, we are trying to calculate the middle point between A and B. So let's consider that to be point M. Sometimes examiner doesn't say calculate the midpoint of point A and B, but he just say calculate the coordinates of M. So if you were told that these two lines are actually equal, then that means for them to be equal, it allows you to use or apply that formula over there. So there are multiple ways in which you can apply that formula. So it doesn't really matter that much in terms of which format you use that formula, but we are only interested in you giving us the final answer in a form of the coordinates. So let's see. So obviously, the x value of point M, you can just say it's going to be the first x value, you add it with the second x value, then you divide it by 2. So what is the x value of the first point? So let's see. We are dealing with Q and N. So I'll just write those coordinates here so that we can easily work them out. So let's see, what are the coordinates of Q? If I remember, for Q, it's actually 4 and -8. And then for what? For N, what is it? It's 8 and 0. So it's better to just follow alphabetical order. Let's say for example you are given the coordinates as A and B. So A comes first. So just use x1 as your A and then use your x2 as B, because A comes first and then B comes second. So let's see, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. No. Which one comes? A, B, C, D, E, F, G,
L
H, I,
M
J.
N O Q.
Oh, yes. You get it. If you don't get it,
Forget about it.
ladies and gentlemen, she says N comes first. So that means this is our x1, this is our x2. So that means we are having 8 plus 4 divided by 2. What is that? That plus that, 10, 11, 12 divided by that, I think is 2. Okay, so if that is the case, ladies and gentlemen, let's now try to continue to the next part of our answer. So we are now trying to calculate the y value of M. So we have y1 plus y2 divided by 2. So let's see, what is y1? So this becomes our y1 because this is our x1. So our y1 is going to be what? 0 plus, so what is our y2? There's our y2. Can you see? It's a negative value. Very, very much important that you put it inside the brackets, ladies and gentlemen. Then you divide by 2. So let's see. What is that? 0 minus 0 plus that is actually negative that. Negative 8 divided by 2 is negative 4. So that means, ladies and gentlemen, the answer there, it's actually negative 4. But remember, guys, it is very, very much important that you write your final answer in the correct format. So finally, you must say M, it's actually 6 and then again negative 4. If you do this, I'm telling you guys, for the x value of M, I'm going to give you a mark. For the y value of M, I'm going to give you a mark. And this is exactly how you score yourself 2 marks. I hope that made sense to everyone. Just in case if there's someone who's got a question on that one, just let me know before I move to the next question. Is everyone happy there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Let's now move to question 3.2. Calculate the gradient of NS. What is the cream of the question? Already I'm able to notice gradient is the cream of the question. So I know a gradient formula might be necessary in that case. Write it down. It's change in y over change in x. What is change? Change, it means the second minus the first. So in this case, it's changing y, the second minus the first. So you can see that you will need two values of y and again two values of x. That means you must know the 2 points that you're dealing with. So can you see? These are the 2 points that you're dealing with. So that means you are actually calculating the gradient of ns. So where is n? There is n. Where is s? There is s. So what you simply do, ladies and gentlemen, is just to write the coordinates of what is it? N and S. Again, which letter comes first?
N, sir.
Okay, so let's write N first, and then the coordinates of N is 8 and 0, and then the coordinates of S, there we are having a 0 and negative 16. Okay, so the question said calculate the gradient. So don't waste time, guys. Just say M of ns, it's equals to y2 minus y1 over x2 minus x1. It doesn't matter if you say a y of s minus y of n over x of s minus x of n. It makes it easy because when you substitute, you know what is the y value for s. What is that? Y value for s is negative 16. Remember, when it's a negative number, put it inside the brackets. I've given an example yesterday to say, if you've got a pot, for those of you who like baking, if you've got a pot and it's hot, it's hot, it's hot, it's hot. These are negatives, guys. It's hot, it's hot, it's hot. For you to handle it nicely, you must be having some hand gloves. Hand gloves being the brackets. I'm telling you, Shreyas, if you touch this pot without the hand gloves, hey, you are going to dance, man. I'm telling you, you'll be in a very strange competition where you'll be dancing just for touching this thing without having your hand glove. I can imagine you, Shreyas, dancing there. And they're asking you, which song are you dancing for? And you can't answer because of you are still feeling the pain. So, ladies and gentlemen, that means at all times when you're dealing with a negative number, make sure that you put it inside the brackets. If you don't, you are going to get bent. You get it. If you don't get it,
Forget about it.
forget about it. Let's see. Minus, what is y of n? Okay, y of n is 0. Okay, over, what is x of s? X of s is 0 minus, what is x of n? Just make sure I don't make a mistake there, ladies and gentlemen, because it's easy to make mistakes. Okay, someone punch all of that and tell me what answer are you getting there?
2.
So someone is getting 2. Last one to confirm.
Sir, I'm sorry. Is it necessary to put the numbers in brackets?
Hey, who's asking? This is the one who didn't get it. Who's asking?
Tando.
Tando. Outing Zame.
Yeah, so I got 2.
Okay,
2,
so
sir.
okay, all right, no. It seems like 2 is the correct answer. So Tando, I wanted to give a talisman, an explanation in Zulu. Uguti, maune pot, ekwele, ngephuthu. Le bodo le liyachisa ngithi. Manje, maselchisa, ene, ufuna ukulibamba. Mase ulibamba ngesandla, lisokushisa leli bhodo le. And futhi kakhulu kabi. Manje kungcono mawusolibamba olibambe ngama gloves ukuthi ungachiseki. So In short, I'm saying, Tando, always, when you have a negative number, put it inside the brackets. The reason to that is because sometimes if you don't put, or if you don't get used to putting them inside the brackets, when you're using this formula for a negative b plus or minus square root of b squared, whatever, over whatever, most of you make a mistake there of not substituting in brackets. So that's where you get bent and you're going to get a 0 marks. So we also use this formula to factorize. That means if you use it to try and find the factors, you will get bent. Tando, iyazwakala lapha. Izwakele.
Yes, sir. Sengiyakuthola.
Uyangithola manje, uyangibamba manje.
Yes, sir.
Ngoba uthando ungibambile, masicubekeni. Let's see. Where am I going to give you some marks? So for you to substitute N and Q, or N and Q, or Q and S into the gradient formula, I'm going to give you a mark. So that means there I'm going to give you a mark, ladies and gentlemen. And again, for the correct final answer, I'm going to give you a mark. So this is exactly how you score yourself 2 marks. I hope that was a straightforward question and everyone is happy there. So let's try to check what is the next question saying. So let me just remove all of these so that we start on a clean slate. Okay, so let's see, ladies and gentlemen, what is the question saying over there? So the question says, which is 3.3, show that the equation of the line LQ is equals to that. What is the cream of the question? Firstly, I notice this is very, very much important. And again, that word is very, very much important, the show. And then this one is very, very much, it seems like the whole of this, it's important for you to pay full attention because it guides you in terms of what to do for what and how. So they are saying show. How do you show? You show by means of calculations, ladies. So there you need to apply your understanding. So it is an equation that they want you to show. Show that the equation of line LQ. So where is LQ? You need to draw that line of LQ. Let's see if I can be able to draw that line. So there is L and there is Q. So we need to show that the line LQ is the whole of this. What do I know about the line of LQ? I just know, ladies and gentlemen, that when you have perpendicular line, when you say the gradient of the first line times the gradient of the second line, they give you -1. When you multiply the gradient of line 1 times the gradient of line 2, it's equals to -1, only if those lines are perpendicular to each other. So that means if you have a line like that, and you have another line like that, and they form a 90-degree angle, or they are perpendicular lines. So that means the gradient of this line, when I multiply it with the gradient of this line, I must get -1. So it's actually a formula, ladies and gentlemen, that you must always remember. I explained this lesson, that formula when I was doing one of my lessons where I was taking you through this chapter for analytical geometry, covering everything. So now that we know that, ladies and gentlemen, here comes a question. Do we know the gradient of that line? Because that's what we should ask ourselves. Do we know a gradient of that line, guys? Do we know it?
Yes, sir.
What is it?
2.
But wait. Isn't 2 the gradient of NS? Oh, yes, there is NS. So it means we have the gradient of, but wait, whoever said yes, why are you saying 2? Because the line that they are talking about is just from that as a no. They are not even saying that. But tell me, SQ, does it have a gradient of 2?
I think so. So it should have the same gradient
Why?
because it's the same line, I think.
Ladies and gentlemen, so what he's saying over there, he is saying if you have this line from there up to there, and this line is actually connected such that it continues from there up to there. Good people, the very same line, it extends up to there. That means the gradient for SQ is 2, the gradient for QM is 2, the gradient for MN is 2. Why? Because these are collinear. So when we talk about collinear, ladies and gentlemen, we are talking about that point ending there, and again it extends to there, and again it extends to there. So all these points are along the same line. So we call this collinear lines, which means they've got the same gradient. I suppose that made sense to everyone. And again, for those of you who have been attending my lessons previously, I'm sure that you do remember me explaining something similar to that. Okay, so let's now see. That means we can actually say we do have the gradient of the first line. So if that is the case, we can just substitute onto that formula to say line 1 we know is 2, but the gradient of line 2 being a LQ, we do not know. But we know when we multiply the two gradients, they must give us -1. So it means we can try to proceed with this formula to do what, ladies and gentlemen? To calculate the gradient of LQ. So how do we do that? We know that we want to get rid of that 2. So let's just divide by that 2. Why? So that it cancels. And then we remain with the gradient of LQ. Whatever that you do on the left, you do on the right. So it seems like the gradient of LQ, it's actually -1 over 2. I'm not sure if I'm losing you guys over there. Can someone just indicate if we are all on the same page? Ladies and gentlemen, are you still there?
Sir, can you please go back? Just want to see something quickly.
Let me go there.
The -6.
Yes, -6.
So we don't consider that when we are like proving that the equation is that.
Okay, so in this case, LB, it's more like they are saying, do whatever that you can, but in the end, find this thing. So that means whatever that we do, we don't touch that. We just need to make sure that we prove that whatever in the end, it's actually equals to that. Unless if I'm missing your question, LB, but just make sure that with my response, did I answer your question?
Kinda, but then they're saying that show that it's -1 over 2x minus 6. So you see that in this case you don't consider the -6.
Oh, okay. No, now I understand, LB. So in answering your question, I'm going to say I'm not yet done answering 3.3. Did I answer you?
Yeah, it's fine.
Okay. So let's see. Let me do this. So remember, guys, we just calculated the gradient of which line? L A Q. We did substitute that, and then we finally had the gradient of LQ being equals to -1 over 2. But remember, LB, what is the cream of the question? They said, show that the equation. So that means we must show that the equation of line LQ is equals to that. So what we have done is part of answering the question. So how do we show an equation? What type of an equation is it? This is the type of question that you must be asked. So we're dealing with a straight line. So that means in you showing, you must be having a straight line equation which says y is equals to mx plus no, not 6. You see now, LB, you're making me to write 6 now. So that one is your fault. That one is your fault. Okay, so let's see. What are we doing there, guys? We're trying to show that an equation is actually... Okay, so what is it that we know about LQ? We already know that we have y being equals to negative 1 over 2x plus c. So we just need a 1 point or 1 coordinates. Let me say we just need 1 point in order to substitute into that formula so that we can rewrite it in the standard form and compare it with what they want us to show. So do we have a point along LQ? Can someone tell me if we've got a point that we can use which is lying along LQ? Do we have it?
Yes, sir.
What is that point?
Q.
Okay, so if that is the case, point Q is 4 and negative 8. So that means, ladies and gentlemen, we need to use point Q.
Sir, I've got a question.
Yes.
So, sir, I've taught the equation of finding the equation of straight line by y minus y1 is equals to m into x minus x1.
Let me write it down. What did you say? Let me write it down. What did you say?
I've just said y minus y1.
Okay, so you've just said y, minus y1
is equals to into x minus x1.
Okay, you said it's equals to, so I must just do that. Into, what did you say?
X minus x1.
X minus x1. So that m, did I have to remove it or do I write it?
No, sir, you have to write it.
Let me write it. So there it is. Ladies and gentlemen, you know how these learners present this type of thing. So he's saying I'm asking a question, but you can see he's not asking a question. He's coming up with option B of solving this type of a problem. I'm telling you, ladies and gentlemen, the reason why I like these lessons, especially with you attending in large numbers, is because we are able to learn from each other, ladies and there are so many ways to kill a cat. So this is the first possible way. So I'm now confirming this is the second possible way, just so that we don't confuse someone over there, honorable member. Let me quickly continue with this method. Then as soon as we're done, we'll try and explore that one over there. So you are on the right track, honorable member. So let me just quickly finish off that one over there. What was I doing there? I think let me just move that a bit up there. Okay, so this is what I was saying, ladies and gentlemen. I was saying we can use this point to substitute into that equation there and try to rewrite it in the standard form. Let's see. Okay, what are we having? So we have our y value being -8, it's equals to -1/2. What is the x value? The x value is 4, and then you plus c. So it's more like we're actually trying to calculate the value of c. So we do know very well that a half of 4 is actually what? Is a 2. So that means we are actually having a -8, -2 plus c. So you just transpose, you remember the song Trias, a Chabalala one side, Maloleka one side. I'm not sure if there's some, I know Lerato has a name is Valoi. Lerato, this song, Chabalala one side, Valoi one side. So what it simply means, it means all the letters to one side, all the numbers to one side. So that's why we are moving all the numbers to one side, and we just have to have letters on the other side. So you are having -8, it changes the sign, it's equals to c. Then what is that? I think this is -c. Okay, so that means c, it's actually equals to -6. Then you can now rewrite that equation in the standard form. So you know your y, it's equals to the gradient. We calculated it to be -1/2x. What is c? C, you calculated it to be -6. So in conclusion, I would say I have proven or shown examiner that, let's see, show that 3.3, show that the equation of line LQ is equals to y, is equals to -1/2 x minus 6. So what honorable member was saying there, ladies and gentlemen, it's simply that as soon as you find the gradient of the perpendicular line, you can use that formula in red over there instead of doing what I've done. So let's quickly see how to go about that one. I'll just write it there again. Let me use that color. So this is okay, guys. I noticed I had a disconnection somewhere, but are you still doing good that side? Let me try to share my screen again. Let's see. Okay, it seems like we are back on track. Someone to confirm for me if all is in order. Are we doing good?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so
Everything is fine with
what
that.
gentleman was saying over there is that so guys, for a few times this might be happening. We'll just have to be patient with that. So it normally happens if something happens to the network. So I'll just continue. If it disconnects, I'll just keep on connecting. I'm sure after multiple connections, it will just connect and we continue without any interruption. So I was saying the coordinates of Q, we had 4 and -8. Okay, guys, let me try this. Wait, start. I suppose I'm now back on track, but if it happens again, I'll just try to connect with my Wi-Fi, because I notice there might be an interruption between the hotspot and Wi-Fi. It could be something technical. Hey guys, Mr. Sibanda is studying IT, so I'm sure after this lesson he's going to give me some tips in terms of how I can sort out this problem that I'm facing. So in case if it happens, I'll just need less than 2 minutes to quickly consult with Mr. Sibanda to give me an advice, and then from there I suppose everything is going to be lit. Seems like we are still connected. Okay, let me just check. Attention.
Yes, sir.
Yes, sir.
100%. So the gentleman who was it? What's your name, honorable member?
Mukhele, sir.
Mukhele. What's your other name? Because hey, it's difficult to remember Mukhele, man.
You can call me Shane.
Shane.
Yes, sir.
Surname?
My surname is Machaya, sir.
Shane Mashele. Okay, it's fine. Mr. Mashele, I'll just try to call it over and over again until I... Okay. What Mashele was saying there, ladies and gentlemen, let me see. No, it seems like the connection is now proper. I think I'll confidently be able to continue. So, what Mr. Mashele is saying there, ladies and gentlemen, is that you just have y and then minus inside the brackets where it says y1 over there. That's where you substitute these values of q. So, what is the y value there? I think it's negative 8. Mashele, just let me continue. You let me know in the end if I'm doing something wrong. So I'm not sure if it was Tando or whoever. Can you see the importance of putting it inside the brackets? Because if you don't, some learners, they just say y and they see the y value there is negative 8. They just write it as negative 8. That's what they'll be dancing. Shreyas is going to show them the type of a dance that they'll be dancing there. It's a very, very nice dance that is unforgettable. So just make sure that you handle it with some hand love. So what is m? I think m was calculated to be negative 1, ladies and gentlemen, into what is x? This is x. You just write it as x. It's only when is x1 or y1 where you put it inside the bracket. So what is our x there of q? Can you see it's a positive value? So it doesn't matter if it's positive, you can still put it inside the brackets, or otherwise you can just write it as. So in short, it's more like if it's negative is hot, and then if maybe is positive, what is the opposite of hot? Is it unhot? What is it? Hot? No, it should be cold. Or if it's
Cold.
not cold, but now LB, if it's not cold, what is it? What is the suitable word? Because if it's cold, you can't just hold ice with your bare hands. What is it? Let's say cool. Nah. How about
Freezing.
cool? Near. You see, now you're going deeper. I think cool might do. What do you think, LB? Let's just say hot and cool. Nah. So that means if it's cool, there's no need for you to put it inside the brackets. But if it's hot, use the hand gloves. Okay, so let's now proceed, ladies and gentlemen. We are having 4, which is a positive value, so it's cool. We can just write it as 4. So let's try to continue. So what Mr. Mukele is saying there, after you substitute, all you do is just to try to rewrite this formula in the standard form. So it's more like you simplify. So you just had to substitute, and then from there, you just simplify. Let's try to simplify and see if we can get to that. So you are having y, obviously this is plus 8. And then you are having this times that times that. So you are having negative 1 over 2x. And then this times that, you are having a positive value. And then half of 4, it's what? Is 2. So you want to move this to the other side so that you just remain with y being equals to, you have negative 1 over 2x, and then you still have that plus 2, but because you transpose, changes the sign. So finally, you are having negative 1 over 2x, and then this minus that is minus that. So can you see the second way to prove that, or to show that whatever it's exactly guys, did I lose you, or are we still together? Did it make sense to everyone?
Yes.
Yes, sir.
Okay, then if okay, same issue again. 3, 2, 1. I think we are now back on track. So what I was about to do, ladies and gentlemen, is to show exactly where you score some marks. So for you to determine the gradient of LQ, we are going to give you a mark. And again, for you to substitute the coordinates of Q, we are also going to give you a mark. For you to substitute those coordinates, doesn't matter whether on this formula or that other one, we're going to give you a mark. And lastly, calculation of C, or the simplification, we are also going to give you a mark. So for that, we are going to give you a mark, and not just you writing C, but to write it in full to say Y, it's equals to negative 1 over 2x minus 6. It really shows that this is what you were actually showing examiner. So I think now we can confidently move to the next question, unless if there's someone who's got a question, guys. This is that opportunity for you to be asking a question before. Guys, anyone with a question? I'm trying to share my screen again. So does it mean, or maybe the message is still delivered? Let me just erase all of this in the meantime. And remember, guys, just in case if everything made sense and you don't have to, you don't have any question, let's not wait, because we'll wait until Jesus come back. So just say no question, or whatever that you can say to indicate that it made sense. Otherwise, I'm telling you guys, we'll be guys, I think I might need to consult with Mr. Sibanda there. I noticed my network is doing some stuff. But before I even do that, did you guys understand that part?
Yes, sir.
The
Jacqueline Mahugo, Lee.
I understood.
Okay,
Understood, sir.
let me see. Adelaide, how are we doing there? Grace, Koleich, is this thing Koleich with a skull there?
Says Cody.
Oh, Koli, so
Yeah, yes, I
Koli.
did understand.
Let me show you guys how Koli is written. For those of you who don't know, let me do these. 3, 2, 1. Can you guys see that skull over there? This is how you write Koli. And guess what? I was calling it Kolei. Hey, yeah. Okay, Tando K, are we good that side? Adelaide, how are we doing?
Yes, sir.
Grace, Sisipo, Hambanjani Lab, Elton, Oh, there's Mukele. Mukele
You're doing
Machaya.
great,
Okay.
sir.
Yes,
There is
sir.
Khunse with a dot. Khunse, how are we doing?
So,
I'm
sir,
good,
I've got
sir.
a question.
Okay, go for it, Mukele.
So, sir, I heard you saying, talking about the collinears. So, I don't understand them. So, can you please elaborate
Okay.
about the collinears, sir?
Let me try to elaborate, ladies and gentlemen. So, when we talk about collinear lines, we just talk about one line. Let's say there it's a line. So, every point that lies along that line. So that means we have this segment. If we have another point along there, we still have this segment. If we have another line there, we still have a segment. So what we are saying there, LB, they normally say, because this is a point, maybe it's point A, this is point B, this is point C, and this is point D. So if you know the gradient of line A and D, so that means everything falling along that, it actually has the same gradient because it's along the same line. So when we talk about collinear lines, we simply mean this line from here to there is collinear to BC, and again it's collinear to CD. So what we know about collinear lines is that they have the same gradient. So that means the gradient, or M, of AB, it's actually equals to the gradient of BC. It's actually equal to gradient of CD. So that's what we mean by collinear lines. So let's check on the diagram if we can be able to identify collinear lines. So can you see you have this line up to there? So, but in between, you still have some points. Can you see you have point L there? So that means S up to L has the same gradient as L up to R, because this is a collinear line. Let's check for another example. So QP, it's collinear to PL. So QP, QL are collinear lines. Yeah, that's how we say it. Let's see again. So M, T, and T, R, these are collinear lines. So that means you can find many examples there. Even this one, and that one. Those are collinear lines. But something that I want you to be aware is that if this gradient, for example, is -2, that means also there the gradient is -2. If this one is -3, also there the gradient is -3. This one, if it's -4, also there it's -4. So this one is a positive gradient. So that means if the positive gradient there is 2, also there is 2, and again also there. Mukele, did it make sense? And did it make sense to everyone?
Yes, sir, I understand.
Yes,
Thank you,
sir.
sir.
Okay,
Yes.
100%. So that's what you should be aware of in terms of a collinear line. So examiner might try to be tricky somehow, such that it doesn't want you to notice the collinear lines and whatever. But you just need to be aware that in terms of collinear lines, you've got equal or same gradients. So let's now try to continue, ladies. Okay, so let's see. 3.4. The question says determine the equation of a circle having center at O, the origin, and also passing through a point S. Before I even go far, I think this one is a question that you might expect in grade. Which grade, guys? Grade 12. So what is the formula or equation of a circle? Can someone tell me?
What's the question, sir?
So what is the formula or the general formula for an equation of a circle. For example, the formula for a straight line is mx plus c. But what is it for a circle?
I said no, I forgot. Wait, is it pi r squared something?
Eh,
Answer.
yes.
Y squared. I think
Is-
it's x squared plus y squared equals to r squared.
Someone is saying x squared plus y squared is equals to r squared. Wait, let's check this one. Pi r squared. No, LB. This one is the area. Nay, I remember. This one is the area, and not the
Oh,
equation of a
okay.
circle. So, okay, it's fine. So, ladies and gentlemen, I think if I remember, someone can just try to correct me. Is it not x? Maybe you have minus a there close, and then you have plus, you have y minus. I'm just not sure if it's a minus or a plus, and then you close that, and then this is equals to r squared.
You're
Am I
correct,
correct?
sir.
Okay.
Yes,
You are
sir.
correct, sir.
Okay. Where have you guys been? Were you waiting for me to write it and say you are correct, sir? You are correct.
Yes,
I
sir.
see the energy there coming through. You are correct. But I asked you to give. You guys. And it's the gents. You know, these gents, they've got a tendency of hiding. When you ask them a question, they hide. But when you give an answer, yes, sir. Yes, sir. Yes. Come on. Ladies, I know you guys, you participate, whether it's wrong or correct. But this gentleman, okay, so ladies and gentlemen, the question says determine the equation of a circle having a center at O. Okay, so let's try to establish that center. So that center is actually there. And at a center, ladies and gentlemen, that's where you have A and B. So let me also do this and create some space there so that it's going to make sense when I explain it for the grade 12s. So can you see, we now have the center there having these coordinates. So when the question says, okay, they've spoken about the center being at the origin, and now they're saying also passing through S. So that means LB, this is a circle, but it has to pass through S. A circle is just O, but it has to pass through S. So that means we must have a circle passing through somewhere, and it must also have a center. So the center there is at the origin. And at the center, that's where we have the coordinates of A and B. So it must be passing through a certain point, of which in this case, they're saying is passing through point S. So that means for you to determine an equation of a circle, you just need the center and again just one point. And we have all of those. So we're just going to substitute. But let me quickly try to draw that circle so that it makes sense. Let's see. So this is how the circle is going to look like, LB. It's just a circle similar to that. But what matters the most is that it must be passing through point S. So let's now try to answer the question. So let me do this and move there and say we are now moving to which question? Is it, what is it, 3.4? And you guys said the equation is x minus a squared plus y minus b squared, and this is equals to r squared. And we know that the coordinates of s, what is it, is 0 and negative 16. No, it's not nicely there. Let me just write like that and say negative 16. And then we know the origin being the center. Obviously, the origin is 0 and 0. So it's just a matter of us substituting there. What are we having there? So we just have x minus, what is a? A there is 0. And then you square it plus y. what is b? There is b being 0 squared. This is equals to, what is r, ladies and gentlemen? So r is the radius. Let me try to explain something there so that you understand what is r. RLB is the distance from the center all the way up to the edge of the circle. So a radius can also be that line, it could be that line, it could be that line, as long as it's from the center radiating towards the edge of a circle. But now, why are we interested in the radius of that line? Is because we know the coordinates at point S, and we know that the distance from the center all the way up to there, it's actually equals to 16. So that is why we are saying the radius is actually equals to 16. So I hope that makes perfect sense to everyone, which is the reason why we are going to substitute our 16 in there. Here comes the question: is it really necessary to substitute it as negative 16? No, it's not. Why? Because anything that you square, you are just going to have a positive value. And again, the radius, you remember, even in trigonometry, we say the radius is always positive. So that is why it's not really that much necessary to write it as a negative value there. So let's see. X minus 0 is just x, and then you square it, then you have x squared, plus y minus that is just y, and remember the square, you square it, it's equals to, what is this thing on a calculator? Can someone use their head to tell me what is that? Hmm?
156.
56. What is it? Is it 56?
256.
Oh yes, 250. But wait, guys. I said use your head. Did you guys use your head or a calculator? You will hear liars. Listen, LB, listen.
Later.
What did you guys use?
Calculator.
Oh, okay. I thought someone was going to say they used their head, but you guys are not following instructions. But it's fine. At least you got the right answer. Okay, so ladies and gentlemen, this is exactly how you score yourself 2 marks. Where exactly are you getting those 2 marks, ladies and gentlemen? For you to identify the radius, that the radius is actually 16, we give you a mark for that. There's no need for us to be checking there whether it's worth giving you a mark. It was just an obvious substitution there, but for you to identify the radius being 16, it really shows that you knew what you were doing there. And then for the whole of this, that's when we actually give you a mark, and this is how you score yourself 2 marks. Did it make sense to everyone? Are you all happy there?
Yes, sir.
Okay, so let's see. The next question now, it says, let me just remove all of that. I gotta need a power bank. I'll just remove all of these. Okay, so let's see, guys. What is the next question say? The next question says calculate the coordinates of. So can you see, guys, the coordinates, this word is the cream of the question, meaning if we're calculating the coordinates of t in the end, we must say t, x, and y. If we don't do this, we are not going to score maximum marks, because the question says calculate the coordinates of t. Okay, let's try to check exactly where is t on that diagram. Oh, there is t. But how am I going to get the coordinates of t, ladies and gentlemen? Is it not a bit tricky, that one there? Okay, but it's fine. What do I know? There's something that I know. I know very well that these two lines are actually parallel to each other, which means if I know the gradient of let's say L and Q, I can easily calculate the gradient of RM, or otherwise TM. Let me just say of TM. Let's see. And then from there, I can easily use one point. Which point can I possibly use? Let me see. Okay, no, that's not what but it's fine. Let me just use that to write. So can you see? I know that point T, there's something that I know there. I know that, what is it? X, it's 0. It's actually the Y value that I don't know exactly what it is. So I think this is the approach that I can actually try. But what about parallel lines? We know very well, ladies and gentlemen, that if you have maybe, let's say, the gradient of L and Q, it must be the same as the gradient of, let's say, T and M. So do we know the gradient of LP, ladies and gentlemen? Do we know the gradient of LP? Hey, am I alone now? You see, now everyone is quiet and I'm no longer sure if we are still attention.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, we're still together. But do I need to explain that again, or did it make sense to everyone?
So just explain it again.
Okay, so let me remove all of that, LB. Oh, I think I've got a better way of actually explaining this thing, guys. Let me just try if that has improved there. Let me just try something there. Okay. I think now I'm going to have something which is improved. Okay, so LB. Here I'll talk about parallel lines. Parallel lines. So when you have parallel lines, gradient of line 1 is equals to gradient of line 2. So here on this side, let me talk about perpendicular lines. Let me just write it down to say perpendicular lines, and underline that, and then here underline that. So LB, when we're dealing with perpendicular lines, that's where the gradient of line 1, when you multiply it with the gradient of line 2, this gives you -1. So can you see that in this case, the question is talking about us trying to find the coordinates of T. And where is T? Can you see? There is T, and T is along that line. And we know that line, it's actually parallel to that line. So what we know about parallel lines, we know that the gradient of line 1 is equals to the gradient of line 2. So the question is, do we know the gradient of that line? Do we know it?
Yes, sir, we do.
What is it?
I think it's 2. Yeah, it's 2.
Nah. It can't be 2, bro.
One negative 1
Nah.
over 2, sir.
Nah. Is it Mukhele?
Negative.
Who is it? Who's speaking with that voice? Was it you, Mukhele? No, bro.
Yes, sir.
No, bro.
Yes.
There I disagree, bro.
It's negative 1 over 2, sir.
Yes.
1 over 2.
No, not 1 over 2. No. Okay. Mukhele, thanks very much for giving us the wrong answer. You will understand why I'm thanking you for giving us the wrong answer. So, ladies and gentlemen, always when you have no. Let me try that. When you have a Cartesian plane, so if you have a line in that direction, always you have positive gradient. Always. So that means, let's say from quadrant number 3 to quadrant number 1, or from quadrant number 1 to quadrant number 3, we always have positive gradient. So that means even when you're calculating gradient and it's a line from passing through those quadrants, you expect a positive gradient. So these lines in that direction, negative gradients. So that is why, Mr. Mukhele, I was saying it can't be a positive value. It doesn't matter whether you said positive 1 over 2 or positive 2, whatever, but it can't be a positive gradient. It has to be a negative gradient. There's a lady who said it's 1 over 2. It's not 1 over 2, but it should be negative whatever. So I can agree with someone who says, Mukhele, does it make sense in terms of gradient being positive or negative? Does it make sense?
Yeah, sir, it does, sir.
Okay, so that means next time you won't give us the wrong answers, man.
Yes, sir.
Okay, more nice. Let's see. What was I doing over there, ladies and gentlemen? Okay, LB, are you happy up to this point?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. I don't want to group in. A group of John, I'm not going to that. I'm not thinking.
God, this is so embarrassing.
No, my way, you took away.
Guys, please, can you respect?
Sir, are you still there?
Guys, I was asking LB if that made sense. So I noticed there was a disconnection again, but I'm not sure if LB got my question, because after that question, I went on to continue to explain something. LB, did you get my question, or was it the issue of network there?
What was your question?
No, I was just asking if that made sense, because you asked for that to be re-explained.
No, yeah, it made sense.
Now it makes okay. So this is what I explained after I asked you that question. I suppose you guys didn't get it. So what I said was that now that we know the gradient of this line, so that means the gradient of this line also is actually equals to -1/2. Mogele, do you agree with me on that one now?
Yes, I do.
And do you understand why?
Nah, I don't understand, sir. Can you repeat it?
Nah. You see, Mogele is disappointing me now. He agrees, but he doesn't understand. Okay.
So wait, didn't we already calculate the -1/2 as the gradient?
Guys, I was about to explain to Mogele there, but I noticed I got disconnected. I'm not sure if that learner did what they did, but I suppose it could be an issue of network on my side, but it's fine. Let's try to continue. So, Mogele, I was trying to say, just make sure that you don't allow me to continue without you understanding this part, because if you don't understand this, it will be asked in a different manner of which you might not be able to answer. So, for you,
So, sir, I do understand because you said line LQ is parallel to line RM. So the gradient of line LQ is equal to the gradient of line RM.
Mukele, I got disconnected. I couldn't hear what you're saying, but I'm back now. Can you try to say what you were saying there?
So, sir, I've got a little bit. Oh, okay, sir.
What did you say, Mukele?
No, you were right. Continue.
No, but you see that English, it came out of the nose, man. Just make sure that that English is not coming out of the nose, Mukele. I didn't hear what you were saying. What did you say?
So, sir, yes, sir.
Yeah.
So, sir, the question paper doesn't appear, so
Oh,
I can't
okay. Let
explain.
me try. Is it still? I think the screen is still sharing. Is it? Are you able to see now?
Yes, sir. The reason why you are
Okay.
saying the gradient of LQ is equal to the gradient of RM is because LQ line LQ is parallel to line RM, so their gradient are going to be equal.
Yes,
Yes, sir.
Yes. Now you are getting it. So that means that line and again this line, because they are parallel to each other, then it means they've got equal gradients. And again, remember what we said about collinear lines. We said this line and also that line, they have the same gradient because they are collinear. Similarly, there and again there. So that is why you are right in saying the gradient, the gradient of RT is still equals to the gradient of TM. So it's just a matter of you deciding whether to write it this way or that way, depending on what the question asks you. And again, here, the gradient of LP is still equals to the gradient of PQ. But in this case, can you see, we do know that the gradient of PQ, what is it? We know that it's negative 1/2. And because we know this line and that line, they are parallel to each other, that means this line also, its gradient is negative 1/2. So this is all that you needed to know regarding a parallel line. So now let's try to answer that question so that it makes sense. So 3.5, what you do, you say the gradient of what? The gradient of RM is equals to the gradient of what is it? Let me just check that question paper there. So we are saying the gradient of RM, yes, is equals to the gradient of LQ. Okay, I think now I'm getting it, and I'm hoping also you guys, you are understanding that part. So what is that gradient, ladies and gentlemen? That gradient, you said it's negative 2. So this is your starting point. And then from there, because you want to calculate the coordinates of t, what do you know about t? You know y is 0 there, but you don't know no, you know x is 0, but you don't know the y value. So that means you then use the straight line equation to determine, because you know this is the gradient, and then x plus c there. At which point? At point t, where we know x is 0, but we do not know what is what. We do not know what is the y value there. I'm just hoping that what I'm doing there is the correct procedure. Let me quickly check something over there. So the question says calculate the coordinates of t. T, we know x is 0, but we don't know what is y over there. So we know that we've got parallel lines over there. Yes, that's correct. And then because we've got parallel lines, let's see. Okay, it seems like we might need 1 point. We might need 1 point that we can use. I want you guys to notice something there. Let me do this. I think I'm now getting to what I want to explain. So remember, guys, what I'm doing, this is what I would do when I'm practicing if I'm in exam. The difference is that if I'm in exam room, I'm going to be at a faster pace. But if I'm practicing, I'm doing it at a slower pace. So can you see? It seems like I cannot use the coordinates of t. Why? Because I don't know what is that. So that means if I had to use the coordinates of t, I would not be able to substitute the y value and again the x value and calculate c, because I know after I've calculated c, I can easily get that point. So do I have another point along that same line? this is what you guys can try to answer. Do I have that coordinates? The coordinates of t I know is just 0 and unknown. Do I have the coordinates of m?
Of n.
No, m.
Yes.
Really? What is it? Do we have the coordinates of m, guys?
It's 6 and yes, sir.
What is it?
It's 6 and
6 and
-4.
-4.
Oh, yes. So that means if we have the coordinates of m, can you see we can use that point to determine an equation of that straight line. So let's see. You're saying it's 6 and -4. Okay, let me now try to substitute that. So you're saying y is -4, and again, you are saying x is what? You're saying x is 6. So can you see I can find the c value? Let's see, what is the 6? What is half of 6? Half of 6 is 3. So it's -3, you transpose is +3. So that means you have -3, you transpose all of that. You can still transpose it as half of 6. Because you just change the sign and then this is equals to c. So that means c is actually equals to what is it? Is it not -1? I think it's -1, guys. So that means the straight line equation is actually -1/2 x minus 1. What is this, guys? I'm going to show you what is this. So this thing, it's actually
Sir, you are cutting. I can't hear you properly.
Is it cutting for everyone?
I can hear you.
Remember, Mukhele, it could be that on your side the network is poor. So in case if someone confirmed that I'm not breaking, then I'll just continue. But just make sure that the part that you missed, you watch this lesson to catch it up. Okay, let's see, ladies and gentlemen, what are we doing and where are we? What was it? Okay, I was saying, what I've just calculated there, it's actually an equation. Let me also remove that. It's an equation of that line. So that means I can calculate any point along that line. Can you see? I can calculate even t there because it lies along that line. And I know the formula there. So what are the coordinates of t? I do know what are the coordinates of t. We said t there, x value is 0 and that one is unknown. So let me substitute. I don't know what is y of t, and this is what I'm calculating, by the way. This is equals to -1/2. What is the x value at t? It's 0, guys, minus 1. Then you just punch all of this on a calculator. Can you see? This thing times 0 is just 0, so you end up having -1, which means the coordinates of t is actually 0 and -1. I'm not sure if I lost you guys there. Just indicate if you are lost. Attention.
Yes, sir.
You're still there, LB. So, are you still thinking if you are lost or not? You can take your time to think, as long as you just confirm that
I'm
you're still
not lost.
You're not lost. Okay. Anyone else? Are we on the same page? Let me see who is on the line. Okay, we have LB there. We have Colleague. We have Dot there. Is Khonse Mukele is there. Grace is there. Molefe, Jacqueline Oketan. Guys, are we doing good? Are we all on the same page?
Yes, sir.
Okay. Then in that case, I think we'll be moving to question 3. What is it? is 3.6. 3.6, yes. So 3.6 there, ladies and gentlemen. What is 3.6 let's see. 3.6, it says determine LS over RS. This is one of interesting question, ladies and gentlemen, where you might find that you need to apply some laws or rules over there. Is there someone who wants to try that 3.6 in terms of how can you approach that question? Remember, guys, in case if you've got no idea, just comment to say no idea, because we will be waiting. No idea, ne?
No idea, sir.
Okay, so let's try to check something, LB. If you have two lines, let's say if you have this, if you have this line and again you have that line over there. I'm not sure if you guys remember the proportion theorem. Did you ever hear about the proportion theorem?
No, sir.
No, sir.
No, sir.
Okay, let me try to explain it. I'm hoping that I'm going to win in explaining this one. I'll just try my... Okay, so the proportion theorem, ladies and gentlemen, remember, this is what the question wants you to determine. They just want you to determine that ratio of LS over RS. So that means you are concentrating on that length or that distance of LS versus that distance of RS. So ask yourself this question: where is LS? Let's see. There is LS. And again, where is RS? There is RS. So up to what I've explained up to this point, does it make sense in terms of how to interpret that question?
Yes, sir, it does, sir.
Okay, so what the proportion theorem says, it therefore says that means a PS over TS, it's equals to LS over RS. So in short, it means, let me just remove this thing. I'm just suspecting someone is getting an idea of what I'm talking about. So that means LSPS. So that means P, this thing is equals to PS over a TS. I'm going to explain it again, but before I do, is there someone who's got an idea of where I'm going with this proportion theorem thing? Is there someone who's having an idea with what I've just said?
Yes, sir.
So it's more like, ladies and gentlemen, if you've got a triangle, that's why I drew that triangle to say, if you have, let's say, a triangle, no, what are you doing? If you have a triangle, let's say something similar to that, and this is A, this is B, this is C. if you can have another line, let's say this line being like that, for as long as this line and this line, they are parallel to each other, ladies and gentlemen, it means in terms of the ratios, you can say, obviously we subdivided that. Let's say maybe this is ABC, then this is D, and this is E. So what the ratio proportion proportion theorem says, it says that means this over this can be equated to this over this. I'm not sure if you are now getting me, guys. Am I losing you guys?
No, sir, we understand.
Okay, so we can still use that same theorem to then try to answer this question. So that means this is actually equals to what is it? Is it not, based on what I've explained, is it not equals to PS over TS? Does it make sense there, guys?
Yes, sir.
Okay, if that is the case, do we know what is PS? Remember, PS is the length. Do we know what is PS?
No, sir, but we can calculate it using the distance formula.
How can we calculate it? Can you just explain in terms of what are we going to do to calculate that?
So remember in 3.3, we were showing that LQ is the equation of line LQ. It's y is equal to negative 1 over 2x minus 6. And we know that that negative 6 represents the y-intercept
of P.
Yeah, yes, of P.
Yeah,
so the coordinates of P, it's actually 0 and negative 6, if I'm not mistaken.
Can you hear?
Yeah.
She's feeling herself. She know that is correct, but she's just saying, if I'm not mistaken. I know you, learners. Okay, continue. But who's speaking? Can you see now? I don't know her voice.
Sir.
Yes. What is your name again?
Oli.
Oh, it's Colleague. Okay, continue.
Yeah, so sir, since we have two coordinates, we can be able to use the distance formula to calculate the length.
Yes. So that means we can calculate PS from there up to there. We can calculate that, isn't it?
Yes, sir.
But what about TS? Can we be able to calculate TS?
TS. Yes, sir. I can see on the previous question we were calculating the coordinates of T. So we can use the we already have the coordinates of S. We can still use the distance formula to find the length.
So Toli, I'm going to tell you something. I'm not sure if it's going to change your your life. But let me just make a statement, guys, to say Polish is 100% correct. So if during our time, my teacher Koli would say, "Welwele," then after a few seconds, he's going to say, "Matso, I know you are not paid, Koli, but can you try to interpret what I've just said?" Welwele, Matso, can you interpret that? Yeah.
Oh, like ezandleni.
Nie, elwantombo.
Like I understand this.
Who's paid in this group? No paid. So, Koli, it's more like you have fought. That's what I'm saying. Elwantombo. Elwa as in you have fought. Yes. Then the second part of it, which says matzo. Do you know what is matzo?
Izandla.
Izandla. So it's more like you have fought. Then after a few seconds, he says clap hands. So that's what it means. So I'm just not sure how that can be done in this group, because I know your parents, they might be sleeping there. And if you start clapping your hands there, you seem like you are crazy. Just imagine in wherever you are. And you start clapping. LB, what possible way can we do this thing? In case if someone says something productive, then here I'm saying Koli, we lwele. Then after a few seconds, when I say matzo, how do we clap hands without making noise, guys?
You can just say well done.
Well done. So, okay, wait. Listen to this. Can you hear? Can you hear me when I do this?
Yeah.
Can you guys hear me?
Yes, sir, we can.
Guys, let's not be jealous and try it. Kolile. So this is what I'm saying.
Yes, sir.
Matso.
I was said cringe.
Yes, sir.
Okay, LB, I know your name very well. So next time when I do it, if they don't get it,
forget about it.
They must forget about it. Okay, so
say you want us to look crazy in front of our parents.
So Kelly, what I wanted to say is that always, when you have points lying along either the x or the y axis, don't worry about the distance formula. You can just say, you know that from t to there. Okay, let me not even say that, but maybe let me do this. Let me do this so that it's explained better. You have the y and the x-axis, and then you have 2 points there being A and B. And here you have 2, there you have 4. So instead of you using the coordinates of 2 and 0, and again the coordinates of 4 and 0, you can just say, Koli, you know that from there to there it's 4, and then from there to there is 2. Why not just say 4 minus 2 and you get 2? So that means from there to there it's actually 2. Then if you are dealing with values, let's say there it's negative 2, and maybe there it's negative, let me just say 5. So this is the distance that we are trying to establish there. How can we do it? Can we not say it's actually negative 5 minus negative 2? Just like you did there, you said that minus that. So what is this one? It's obviously going to be a negative 5 plus, what is it, plus 2 being -3. So it simply means there the distance is actually 3 and not -3, because remember, distance is always positive, just like the radius always being Toli, did that help, or did it make sense? You only use the distance formula if maybe a point is there and another one is there within or inside the quadrant. Then you have two lines. That's when you use the distance formula. But if it lies along the axis, you can just say this number minus whatever number, and then you're going to get the distance in between. Did it make sense, Toli?
To understand.
So, do you think you are confident to try and answer the question that we're dealing with without you having to use the distance formula? Do you think you can give it a try? Or should I try it? Let me explain it, guys.
Oh.
Okay, no, it's fine. Let me explain it. So what I was saying is that we know there we have a -16. And what was P? The coordinates of P, X is 0. And I think you said there why it's -6. And then this one, we know we have 0 and again -1. So what I'm saying there, ladies and gentlemen, is that for us to calculate this distance, you can just simply say, what is it? It's -16. So put it inside the brackets and say -16, and then you minus t. What is t? T is -1. But before I even do that, let me just make sure that I follow the ratio there. So let me do PS. Okay, where is P? P is there. P is -6 minus what is S? S is that one there. Okay, so that means I must subtract S. What is S? S is -16. Then you minus P. What is P? P is -6. What are you getting there when you punch that? Let's see. This is plus that. I think it's negative. No, it's 10. It's -10. Is it not negative? Can someone just confirm for me there?
-10.
That, I think you're getting -10, eh?
Yes.
But we know, because we're dealing with distances, we're just going to say it's actually 10 units. So that means you can substitute 10 there and say over. Let's now do for TS. What is TS?
So it's
there?
-10.
So remember, LB, distance is always positive units, just like with the radius, or R. So R is also a positive units. That is why, LB, you will never ever, when you use the distance formula, get your distance be maybe -2 units. You will never. Does it make sense now?
Yes, sir.
So always when you're dealing with the distances, just make sure that you are only concentrating on that value. So you can ignore the negative sign that you get in there. So let's see again, guys. What about TS? Okay, there's T, there's S. So that means you're still going to say in brackets -16 minus inside the brackets. What are we having there? What is T is that? So what is the answer for this one? I think it's -60, -15. Yes, it's -15, but because we're dealing with a distance, then it's actually +50. Guys, are we still together? Am I not losing you?
Yes,
Is it everyone who's on the same page with me there?
yes, I do.
Okay, so that means there we are having 15. when we punch this thing on a calculator, does it give us something? What are we getting when you say that 10 over 15? What are you getting?
2 over 3.
3.
2 over 3. So can you see, guys, this question is allocated 3 marks. Anything allocated 3 marks is not that much difficult, but that means you must know this theorem and you must be able to interpret them. So can you guys see that if you do not know how to interpret the theorem, you won't be able to then get the correct answer. So this is where you score your mark, this is where you score your mark, and that ratio, that's where you score your third mark. I'm not sure if that makes sense.
That that negative one, where is it coming from? It's from the point N and O, and then T.
No, -1 comes from point T. I think point T, I think it was -1, isn't it? The coordinates of T.
Oh, okay, now I see it now.
Yeah, so that's where it's coming from. So it's coming from the coordinates of T. So can we confidently move to the next question now? Let me maybe write this thing. I'm not sure if you guys are going to need this document. I'm not sure. Guys, are you going to need this document? This thing that I'm writing on the memo.
Yes. So that when we practice on our own, we can just compare.
Oh, okay. Then just make sure that I post it in the group, LB. I leave it your response. And you know, LB, I know, as soon as the lesson is done, boom, you're gone. Your Telegram is off and I forget to send this information. Someone will be saying, hey, you promised what. So just make sure, LB, that as soon as the lesson ends, if you don't see me posting this thing after an hour, just make sure that you let me know. So let's see, 3 point that we actually said L S over R S. This is equals to, we said it's equals to PS over TS. And we did some calculations up until we noticed that it's actually 2 over 3 there. Maybe let me try to check what calculations did we say. I think the first one we said negative, what is it? Negative 16 minus, what was it? I think it was negative 6, and this was equals to what? Let's say.
Can you please state that theorem again?
Okay, so that theorem, let's say, is proportion theorem. So, in short, it's more like we are actually saying, we know that RM is parallel to LP. Let me just quickly check if what I'm saying is right. RM is parallel to RT is parallel to RT is parallel to LP, yes. And for that reason, then it means we can apply all that I've explained using those colors to say the ratio of this line over this line, it will be the same as this line over that line. And the reason to that is because we are having two lines which are parallel to each other. I'm not sure if I've tried to respond to you, honorable member.
Yes, I understand, but I wanted you to state it. Like theorem of proportion states that.
Oh, okay. No, I see. Let me just quickly try to check. Possibly there's someone who's good with stating this theorem. Is there someone who wants to try and respond to that question? Because you know, theorems, they are many, and I've just prepared for this one. So it's unfortunate during our time we did not do, what is it, Euclidean geometry. So I still need to study that chapter and present it on winter. Okay, guys, before I even forget, just make sure that if you've made a payment for last month, just inbox me with your proof of payment. Then I'll add you to the group for winter classes. So if you've made a payment for whatever package that you chose, then you won't be paying for what is it? You won't be paying for online for winter school. Just make sure of that before I forget. So that's what I wanted to say. But anyway, is there someone who wants to state that theorem in terms of what it says, the proportion theorem? If not, then we'll just leave it as our homework. I'll also check it, and you guys also just check it so that we know exactly what it states. So in this case, I've just applied it. So what I did, it was the application of that theory. So Mukhele there, he wanted the definition of that, or he wanted us to state that theory. So in case if there's no one who's there to comment on it, Mukhele, can we say what can we say we leave it as our homework? Can we agree on that?
Yes, sir.
Okay.
I agree.
Okay, then it's fine. I think quickly, let's try to go through this last question. So, guys, can you see the reason why it's important for me to record this lessons? Is someone who's probably having some assignments or whatever that they are preparing for, and they couldn't attend today's lesson. So when I have it recorded, I can still play it sometime. So just make sure, ladies and gentlemen, that before the end of this lesson, we try to check if when I play a recorded lesson is going to play nicely. Just remind me before we finish today's lesson. So let's see. This question says, okay, but before I do that, LB, let me show you. Okay, you see now, I wasn't done with that. What did we say there? What did we say there, guys? I think we also had negative 16. And then we said minus negative 1. We got what? 15 units. And I said, for you to substitute that, you get a mark. For you to that, you get a mark. And again, no. Can you see, guys? This is a shortcut. You won't score full marks there. So that means you must actually say 10 over 15, and it gives you 2 over 3. In that way, you'll be able to score a mark there and again there, and then that ratio is given a mark. But still, don't worry, even if you did not do 10 over 2, you might score some marks there. But just make sure to write that ratio in that way, and then you can simplify it afterwards. So LB, I'm trying to make sure that I write everything so that when you practice, you can easily refer to that document. Okay, so let's now try to have a look at the next question. So the next question says, calculate the area of PTMQ. So this is what you need to do. Where is P? There is P. From P to T. Where is T? Okay, there is T. From T, M. Where is M? There is M. From there, where is Q? Okay, there's Q. So that means this is the triangle that they are talking about over there. I think I might leave this one as a homework to do. So can you see, this is the type of a shape, ladies and gentlemen, that we are having over there. So what is the formula for this type of a shape? Or before I even do that, what is the type of this formula? Is it a rectangle? Is it a square? Is it a triangle? What is this, guys? Is there someone who knows? If you
The
what
quadrilateral.
someone says it's a quadrilateral, and then the other one,
Trapezium.
so LB, you just reminded me of something. What is a quadrilateral, guys? Am I correct in saying quadrilateral is just any side which has 4 sides? Am I correct in saying that?
Yes, sir, you're correct, sir.
Okay, so LB, that means a quadrilateral, it's any shape with 4 sides. So you can have this type of a shape. It's a quadrilateral because it has 4 sides. You can have another one, which is this type of a shape. Can you see? It also has 4 sides. Also, this one, it has 4 sides. But we have the names for each of those. All of them, 1, 2, 3, are called quadrilaterals because they have 4 sides. But this one, it's a rectangle. This one, it's a square. And this one, it's a trapezium. Are you happy there, LB?
Yes, sir.
Okay, so now that means you need to know the formula for calculating the area of a trapezium. So the area for calculating a trapezium, let me just write it there, and I'll just give an example. So if you have a shape similar to this one, ladies and gentlemen, and let's say this is point A, this is point B, this is point C, and then there it's point D. The area of a trapezium, it's A, it's equals to half of that distance plus that distance. So it's more like inside the brackets, I'll just write it like this. So it's a half of actually line of A, B plus A, C, D, close, and then you multiply by line A, B, C. Line BC. So that means inside the brackets you multiply by BC. I'm not sure if you guys understand that formula over there. Does it make sense to everyone, guys? Remember, guys, if it doesn't, just comment no idea, or otherwise if it doesn't, it doesn't, then I'll need to explain it again.
No
YB
ideas.
multiplied by BC, sir.
Okay, there's a question. So it's more like, think about a triangle, a square. Let's give an example as a square. What is the area of a square? An area of a square, we just know that it's actually a length times breadth, meaning is this length multiplying by that name. So also area for a triangle, same formula, is this multiplied by that. So also here, let's just apply the same thing. We know that it's going to be that multiplied by that, which is what? Which is this multiplied by that. But can you see the vertical lines are not equal? You have this one which is a bit shorter, and you also have that one which is a bit longer there. So that is why you are having line 1, you add it with line 2, and then with this half, it's more like you are trying to get an average between these two lines. And then that average, it's more like it serves as your length. And then you multiply it with your breadth. So no need to fully understand where that formula comes from, but you just need to be aware that this is exactly how the formula is and it doesn't change. So you just need to know it by heart, or otherwise you can try to explain it based on what I'm explaining there. I'm not sure, guys, if it now makes sense, but let me just give you another example. So if you have this as a trapezium, there's A, B, C, and D, and they want you to calculate the area of that. So the area is going to be equals to, it's always half, and that half, it's because of, can you see, this portion, it was actually a square there, but we have cut it into half. So you can just maybe say this is where that half is coming from, just so that you don't forget that half. And then from there, can you see where you have dealt with that portion of half? Now you are dealing with the length multiplied by breadth. But can you see your breadth is just that one over there? But in terms of your length, can you see you have two different lengths there? That is why the formula, it therefore becomes a length number 1 plus length number 2 multiplying by that. Guys, does it now make sense in terms of how I interpret it there? Do you have an idea of what I'm talking about there?
Yes, sir.
Yes, sir, I do.
So that means when you're given a shape of a trapezium, that's how you calculate an area. So that means you must have the distances or the length. Let's check if there we are having. Can you now see a trapezium there, or is it me who's seeing a trapezium there?
Can see, sir.
You can see, nay. Okay, so that means LB, you need to know. No. Let me bring that back. I don't want to take it away. Let me also use it. So that means on your formula of area, it's going to be equals to half length 1 being that one. So that means you're going to find the length of PQ and plus it with a length of TM. And then you close it, then you multiply it by the length of QM or MQ. I'm not sure if it makes sense, guys. I'm not sure if it makes sense. I'm not sure if it makes sense, guys.
So, sir, I understand. Like I do understand what you're saying.
But there's no but. Mukhele, there's no but.
Wait, so I'm going to have to use the distance formula first to find the length.
Yeah. So can you see now Koli? Was it Koli? Can you see? No. It was not Koli. That one of Matsoho, guys. Who's Matsoho? Who was Matsoho?
Sir.
Who was it? Tando or Tandi. Okay. So LB, can you see in this case you have a point which is along the y-axis and a point which is not along the y-axis. So you are forced to use the distance formula. But if you had maybe this point there and again that point there, you're just going to say this one minus that one, then it was going to give you that distance there. Does it make sense, LB?
Yes, sir.
So that means you will use the distance formula to calculate a PQ and use it again to calculate a TM and use it again. Can you see? Hey, this is a lot of work. And still calculate for MQ. And then from there, you are going to substitute into that formula over there. So I'll just give you a final answer. So the area that you must get, it has to be 25 square units. 25 square units. If you don't get this answer, then you've made a mistake somewhere. So this is me closing today's lesson, guys. I'm not sure if today's lesson, guys, there is something new that you've learned over there, especially you guys who are attending my lesson for the first time. Did everything make sense there?
Yes, sir. The thing that I've learned today is the area of that
A trapezium.
trapezium. Yes, sir.
Okay, no, that's great. There are some stuff that I've also learned in today's lesson. So let me see. I want to try and quickly check something before I close the lesson. Okay. Let me see. Kuli, yes. Okay. I suppose that wasn't that much there. Let me quickly check. Okay, but it's fine. I think I will test it on our next lesson. So guys, this brings us to the end of our lesson for today. Thanks very much, Oli. Yes, LB.
Can I ask?
Don't forget to send the
Oh,
document.
yes. Okay, no, immediately I'll
Sir,
save
can
and
I
send.
ask?
Yes, Oli, you can ask.
Sir, can you show that slide again? That paper.
Let me go back. So you want the question paper?
Yes, sir.
Okay.
Sir, 3.7, the last question. I want to ask if it's possible to do it this way, ne?
Yeah.
Sir, here we have the triangle TSM. Can you see triangle TSM?
Triangle TSM. Yes.
Triangle, I need to say.
Mm-hmm.
Then say, can you see triangle PSQ? The smaller one.
Yes. Let me remove all of this nonsense here, Koli. Let me remove all of that. Then I'll just be doing exactly what you're saying there so that we're on the same page. So Koli is saying, can I see triangle TSM? This is the first triangle, ne?
Yes,
and
sir.
the other one you are talking about, that
The
one
smaller
there.
triangle.
Yes. Continue.
Sir, isn't it possible to find the area of the bigger triangle, then find the area of the smaller triangle, then subtract it to get the area of that shape, the one that we are looking for?
You are 100% correct there, Koli. So I'm going to give you a challenge to say, in your case, do it that way and check if you're going to get 25. So in short, ladies and gentlemen, Koli says, because I know that the area of a triangle is half length times breadth. So what Koli is going to do there, she's just going to calculate that distance and also calculate that distance over there, and again calculate that distance there, and then again calculate that distance there. Hey, Oli, you will have to calculate for 4 distances. Can you see? So from there, what she's going to do is to use this formula and calculate the area of a bigger triangle, and still use the same formula and calculate the area of a smaller triangle. Therefore, she's going to say the area of that PTMQ, it's actually equals to the area of a bigger triangle minus the area of a smaller triangle. Does it make sense, guys? Oli, is this what you're saying?
Yeah. Because do you remember on the previous question 3.6 we did find the length of PS and TS, so we'll just have to find the two lengths only.
Yo. Woza nazo.
Sir,
What am I doing? Yes. What do we have, Oli? You said which distance do we have?
do you remember 3.6, sir?
3 oh yes. Let me
Yes, sir.
remove all of that. Yes. Okay. So what did we calculate?
We're determining LS over RS, and you said LS over RS is equal to PS over TS. Remember, sir? Then
Yes.
then we find the distance of PS and TS.
Yes.
Yeah, so it will be easier to use it because we already have two sides. We will only have to calculate the other two.
Oh, and the other two that you're talking about is just this one and that one, eh?
Yes, using the
Oh,
distance formula.
okay. Koli, oilwele, matsoho.
So she deserves a round of applause, like no cap.
So can you see how useful it is when we attend in numbers, guys? So it's not only a positive suggestion which helps us to understand these things. Even the questions, no matter how complicated or less complicated the question may be, it helps me also to expand. And I receive a lot of those from LB since from the day she started with my lessons. Whatever question that she asks, it helps me to expand. I know the other guys, they might not be in today's lesson. Let me see who has attended. So that's what I'm saying.
Hey, this
It's
girl is a
better.
mathematician.
She's a mathematician.
We
She's a
have some smart
mathematician.
people in the
I
group,
think
so
I might call her Matso. From now on, you are no longer a who was it? Is it Koli? Who was it?
Koli, sir.
Koli.
Koli.
Going forward, I call you Matso. When I say Matso, you say
Oh, yes,
Weilwele.
sir. Oh, Ilwile.
Weilwele. Can you say it?
Yes, sir.
What is it?
Ilwile.
Okay, it's fine. I'll just be saying it from time to time, then you won't forget. LB, you wanted to say something?
just a reminder, please don't forget to send.
Oh, yes. Okay, so guys, that was it for today. I'm going to end the lesson. Thanks for joining. I'll see you on my next lesson. I suppose we did learn some things, guys. Just have a good night. Have a rest. I think tomorrow or Sunday there might be another lesson for paper 2 where we prepare maybe for trick or something else. Okay, cheers, guys.